recorded sound usually is fixed once it has been recorded, but we would still like to be able to control what we play back on the base of the sound. And so here we would like to use really perceptually and musically meaningful descriptions of the sound, so describing the content and the character and the timbre of the sound. And another argument is that everyone, especially sound designers, musicians, they have amassed a whole wealth of sound in big databases. Some sound designers, they have at the moment 1 terabyte. No, actually that was 4 years ago. They had 1 terabyte of sounds, so now it must be 4 times that much or so. And the databases are there, and it would be great to be able to use them efficiently, because in 1 terabyte it becomes very hard to go there manually and find the sounds again, unless you're very, very disciplined with making order or so. And so, yeah, it would be great if we could very intuitively browse through and explore these big corpora of sounds with some direct and intuitive access. And as soon as that access involves kind of gestures or some physical means of interacting, a bit more interesting than the mouse, of course, this directly becomes a digital musical instrument with which you can express yourself and expressively explore and navigate through a corpus of sounds. And one technology I know of that enables us to do this is, of course, the real-time corpus-based concatenative synthesis that I started out on in my thesis in 1999 already, where the question first was, can we actually make music by concatenating little bits of sound, as was done in speech 10 years before already? And that answer was yes, but it was kind of, my thesis work was all offline, batch thing, compositional stuff. But as soon as I transposed this into an interactive domain, then it really became interesting and interested composers and musicians, and then it really took off. And so since 2005, one of my projects is about real-time concatenative synthesis. And so the principle here is, of course, the central part is the corpus. And the corpus means segmented bits of sound, automatically or by hand or by content, that we don't care how. Just we have kind of segments, can be very short, a few hundred milliseconds, but up to 1 second, or like meaningful units of sound, notes, phonemes, words, or whatever. And each of these segments would be described by a certain number of audio descriptors that would express the content, like the timbre, but these descriptors can also be attributed to the sound externally. It can be some metadata or even completely subjective descriptors, like the glassiness of a sound or the angriness of a sound, whatever. And the playback is concatenative. That means bits of sound are just stringed together, one after the other, or maybe there's an overlap. And all this happens in real time. That means that the interaction with it becomes a navigation through that space of sound descriptors. And so this approach, we can link this, of course, to granular synthesis, where usually you access the sound, you interact by giving a position, a temporal position in just one sound file. And when we know actually what is in each bit of sound, we can then also navigate by the content. So we can directly play a grain with a certain characteristic we would like to hear. And so, well, time still is considered as just one descriptor among others, but we could now, time has no special meaning for us anymore. And more in general, corpus-based synthesis is more towards a data-driven approach that Roger already nicely mentioned with David Cope's work, where you kind of make use of data in a kind of database to extract information, knowledge about the processes that generated the data. And so the rules would be derived from the data instead of first thinking about some rules and then trying to make these work. And it's always much more difficult to get the rules to generate complex enough things and to be complete in defining the rules. And last, of course, every new method of synthesis, every new technological method, when taken up by creatives, will then enable completely new sound worlds to be discovered, which has been luckily the case in the last few years by the many composers who are actually using these ideas of sound synthesis. And a last link, Lev Manovich nicely positions the database as maybe a new art form. I don't know where we are at the moment. Cinema was the 7th art now. Are we at the 8th, or maybe is comics already taking the place of the 8th? So maybe that's the 8th or 9th art form, who knows? But it's not as new as it might seem, because when looking a bit in the history of music, this idea of using some set of sounds, it wasn't called a corpus, but we could actually identify it as such. This idea was already around in a lot of approaches to music making. Even the very beginning of concrete music, basically every composer had a set of sounds they had recorded, and they would reassemble it according maybe to some rules, certainly not interactively, but to create the composition. And later, sampling has some concepts of corpus also, because you've got all these sounds mapped to keys. Everything's kind of fixed, but still you concatenate different samples if you wish. And I mentioned granular synthesis. John Oswald is a great example of completely manual corpus-based synthesis on a basis of existing pop songs. In his piece Plexure, he used about 8,000 snippets from 10 years of American Top 40, one snippet for each song. And he ordered them, or he had an assistant order them by, I think it was speed and presence of vocals. And so he composed a completely unlistenable piece of music out of 8,000 other bits of music. And from the year 2000 on, with automation and computer technology, all these ideas could now be realized with more and more automation, and that made everything kind of take off, as you see in the the beginning. That is a nice Stockhausen piece, actually called Etude 1, but dubbed the study for 1,000 pieces, because he had a couple of piano recordings transformed, and that's what he would do. He would just, according to a score, cut the tapes up and reassemble it from that corpus of sound that he had defined. And Michael Manet gave me this nice slide about the lore of how to do the concatenation by having different types of cuts to control the transitions. So it sounds very granular already, I think. Or a nice example of Cage's Williams mix, where Cage stipulated kind of 6 classes of sounds, like city sounds, nature sounds, human sounds, and a score in actual size of the 8-channel tape. And I think there were several hundred of these pages, and first realization I think took 3 months, and it has just been redone. First realization was by Louis and B.B. Barron, who also did Forbidden Planet, and it was last year or 2 years ago redone by Daffeldecker and I don't know whom, some Austrians. Okay, so just to show I tried to summarize what's been happening since the beginning. That if you stretch it very far, you can call this a corpus-based music, samplers, blah blah blah, plunderphonics, and then from the 2000s on, Caterpillar was my thesis system, with a huge database behind, so completely unusable, of course. I just mentioned the few ones that are maybe still important. Mad Concat was a very nice trial by Bob Sturm, who is worth checking out because he also thought about the legal implications, and you hinted at that. He made a piece then, he's a very good scientist but also a composer. He made a piece using the temporal evolution or the temporal profile of Mahler, and as a sound base either George Bush or Screaming Monkeys, or some other composer sounds, like I don't know, a guy called Lawrence Welk, seems to be known by Americans. And so then he asked, so whose is this piece by? The temporal shape is completely Mahler. All the sounds are that other composer, and I put everything together. So legally, intellectual property-wise, who's this piece by? And there's also a very nice article by Chris Cutler, I think, about all the plunderphonia thing. And John Oswald also made his pieces actually just to challenge copyright law, with very, very big success. He was ordered to destroy a lot of his CDs just because they had cut up covers of Michael Jackson on them, and Michael Jackson bits and sound grains. We'll see later an example how you can get away with it, using Michael Jackson in art music. And so the other really nice system is Sound Spotter up there, based on Michael Casey's work, and now continued by what's his name? Also from Brunel. So SoundSpot is more a mosaicing type application, but it runs on PD, and it's very, very nice to work with, I think. Maybe the only commercial project is Sinful, here to the right, but that it's completely aimed at orchestra instrument synthesis, but it is corpus-based concatenative because, Eric Lindemann, he did this all alone. He had all orchestra instruments recorded with all different types of transitions, different slurs, small jumps, large jumps, and the system just picks the right transition and the right stable states according to the context, and so it sounds very, very good. And a lot of Hollywood film music composers use this because it's very, very efficient. It can make scores very fast. And then 2005 started the Qatart system that I'm still actively maintaining, and that we'll see a few examples of. So that was up to 2005, and currently William Brent did a great job of basically implementing pretty close to Qatart in PD as a monolithic PD external that does everything. Analysis, selection, resynthesis. Alex Harker did great, slightly more modular stuff for Maximus P. Graham Coleman did nice work on the interface too. And just because it's just too beautiful, make sure to check out the Scrambled Hacks performance by Sven König. That is most musicking, so he actually looks up bits of sound and the corresponding video, pop video, also you have Scorpions and Michael Jackson's on there, by imitating the sound. So if he wants to conjure up Michael Jackson singing, he has to kind of change the voice and to get it right, or if he wants to have a guitar solo sound, he has to imitate guitar. And he trained very, very hard to do this, and it's quite nice. It's too underground for any copyright law to jump onto it, luckily. Okay, and my own implementation is called CutArt. That is in a very, very modular system, or based on a very modular system for Macs called FTM, that gives you kind of efficient object-oriented programming in Macs and very efficient grain or sound atom-based synthesis. That's all free software. There's a new flavor of CutArt coming up based on another set of externals, slightly less modular, but really much easier to use for non-computer scientists, maybe. And there's also, for just people who just don't want to bear with Macs, there's also a standalone application released in the IRCAM forum that has a nice simple interface, MIDI mapping and so on. That's actually what I'm going to show. Yeah, so I think it would be best just to show this so that everyone is kind of knowing what I'm talking about. So that's the CutArt standalone. And it does have the same functionality as the CutArt modular version. And so what I did here, I dropped in some sounds, and the easiest way to interact with this resulting corpus of sound is by navigation. So each point you see here on the 2D display is representing one little bit of sound that is plotted at its location in the descriptor space. And here, of course, it's only a two-dimensional space. So to the x-axis would be spectrocentroid, the brilliance of the sound, and the y-axis, the periodicity. And now a very, very simple interaction is just to move through that descriptor space and trigger sounds as you come close. So what I put in here were 5 different recordings of trains. And of course, everything that sounds similar will be at a similar region in the space. And so all the differences you get from train sounds, they will be deployed here, free for you to interact. And of course, then you've got the extreme points that are in extreme locations of the descriptor space. Let's add some more sounds. Maybe I'll cut them up slightly smaller. So just drop them in. So they will get analyzed by all sound descriptors. Could also use color to represent something else. And now we've got the train sounds. So the speech sounds, they span up a kind of different descriptor space, a bit larger than before. So we have the vowels that take up a specific space, and the fricatives, of course, have a higher spectrocentroid. And even with this very, very basic interaction just with one pointing device without any other expressive qualities. We just by the navigation we kind of make the interaction, we give it a hint of expressivity, because we can still use the speed of movement to control density, for example. And so actually the next part of the talk will consider how we can make the interaction a little bit more interesting and musical and expressive by using different gestural controllers and different affordances of the idea of interacting with the sound space. But first, just you're sure about the name. It's not about cat art. You don't write it with a capital A. It's neither about art made by cats, and certainly not about art made on cats. No, it's just the capital RT for the real-time part. Okay, so who of you were at the concert yesterday? Okay, almost all. So you've seen a lot of these in action anyway. So for last night I made a little survey about how or what controllers are amenable for interacting with the sound space. And of course you get the two big groups of controllers where you specify the position in the descriptor space. Of course usually it would be 2D, 3D is okay. Theoretically it can be ND. Well, we have kind of 20 descriptors, so you could move through a 20-dimensional space, but it's kind of very hard to imagine. So 2D, 3D is usually fine. Or you can control looking up of segments of the sound space by input audio, which means you kind of analyze descriptors from the audio, and these would be used to find the closest matching bit of sound in the sound space. So let's look. So there's a website where a lot of things are kind of documented with video and audio examples. For the three people who weren't at the concert, I will just show a little video using this XY pad. Thanks to the wireless. Well, anyway, I think you got the idea. The nice thing here is that it is very pressure sensitive. This little prototype XY plus pressure MIDI controller that's not produced anymore, unfortunately. And so it's got a tactile surface, and you have to weigh down really hard to get it to the maximum. So it does allow very physical play, which I like a lot. And I would always probably stick with a single touch plus pressure controller. Shut up. Single touch plus pressure instead of multi-touch without pressure. Multi-touch has its advantages too, as you will see. Graphics tablets are very precise, but somehow for performance, you always wind up making these minute gestures to play the precision. And I think for the live aspect, for me, there's something lacking. doing incredible sound with just maybe it's closer to the laptop performance where people hide behind the screens, but for me it doesn't do it. The correspondence between the gesture and the sound is very often, there's a big discrepancy. But yeah, other people might do great stuff with it, I guess, and make use of the precision that you can get. Example of still multi-touch. Multi-touch screens, of course, would be the greatest interface if they just had pressure. Even without it, the polyphony you suddenly get totally changes the gestures you would use, and thus the multi-layeredness of the resulting sound. So you can't see it actually on the screen, but of course there's the dots are on what looks like a white square here, but it just didn't come through in the camera. And so what is nice here is the co-location of gestural input and the graphical information. You actually play on the dots. You're not playing on a blind surface, and the actual information what you play is separate on the screen, which is maybe one of the one weak point for many of these spatial controllers, of course. Okay, another example of spatial control, but in an orchestra setting. Here the input controller was just mouse and keyboard for some shortcuts, and it is a composed setting, but still Bruno Ruviaro, the composer, made a great job in creating a huge variety of sound just out of 2 sound samples. Maybe I just show a very short excerpt, which will not do the piece justice because it's kind of a 20-minute piece, 18 minutes. Just jump anywhere. So it's a very slow-moving piece. I'll jump around a little bit, which is, don't tell the composer. So Bruno's special version of Cat Art for the orchestra also allowed the composer to send instructions to all the players. And so, yeah, there was then multiple layers of interaction between composer and orchestra, and each orchestra member with the sound corpus. Let's see if I actually have the the software here, so I could play you the sound samples too that he actually used. Okay, so that's one. That's one, and the other is. Now, actually worth a study why it's always Mahler and Michael Jackson that get hit as targets for artistic rip-off, isn't it? Okay, so that was a lot. Oh, maybe yesterday I also used the accelerometers of the iPad for positional control. That was the solo piece, and the principle is the same. It's a very direct mapping, just using the tilt of the iPad to control the position in a 2D space. It's really not even a smoothing in between. But what this does, there is not a physical model, but a real physical object, of course, that adds some mapping, that adds some haptics and changes the proprioception. So again, because of this, the interaction will be completely different, because you have to move this physical object, the iPad, and the link between gesture and musical dynamics is becoming very clear again. So now second possibility to control corpus-based synthesis is using audio input. And the general name for this is audio mosaicing, because you kind of reassemble an image, a track out of little bits taken from another track of audio. And the most classical way to do audio mosaicing is by matching the spectra, more or less smoothed version of spectra. That's what Sven Koenig did in the Scrambled Hacks, and Norbert Schnell made some very nice examples based on his Mubu developments for Max. So we always take this phrase.
Elle se garantira du froid avec ce bon capuchon. Annie s'ennuie loin de mes parents. Les deux camions se sont heurtés de face.
And so if we take this as a target and we try to match very small, like frame-sized, FT frame-sized bits of another sound corpus, it sounds like so these are dogs and chickens. Or drink bubbles. Can you understand it? I heard the phrase so often, for me it's totally clear, but probably after just one listen. Contrabass and And one last one. And so these were very, very short snippets to reconstitute the sound, which is great for the reactiveness. But if you want to keep a little bit of the temporal evolution of the source sounds in the corpus, that's not going to make it, because you could pick the start to match something, but it's much more difficult to do temporal matching. And so we actually had a composer work on this problem, Ben Heckbart. He was in the musical research residency at IRCAM, and he developed his own system of mosaicing called Audio Guide that is able to first match the temporal profile, but then also allow simultaneous matching. Because here we always pick just one frame from the corpus to play it back, but he picked a whole input segment, and for Ben it was like, for example, piano clusters or percussion sounds that he left as a whole, but then he would choose a little bit later what other sound he would need to pick and layer on top of the first one that was already running to finally constitute a whole the timbral evolution of the target. I have some examples of this. Okay, first one target, the target phrase.
I then said to David Tudor, the lecture is so soon that I don't think I'll be able to get all 90 stories written.
And his first corpus would be things like this. This is just an excerpt of the corpus. And when he used this to reconstitute the phrase, shall I play the phrase again? Just the beginning, maybe.
I then said to David Tudor,
or maybe another source would be different things you can do with a snare drum. So these segments here would always be used as a whole in the synthesis of, again, the same source phrase. And so you could actually hear the little percussion gesture that always was kept intact, but just layered with other gestures. And for Ben, then later actually it became important to not only strive for just similarity. For him, actually the degree of similarity, he wanted this also as a compositional parameter. And so I made a little interface with him where he could again browse through a corpus of a solution space of his algorithm. He could browse through the corpus of all different parameterizations of his matching of similarity. And so he could start with something that sounded very dissimilar, then jump to another solution that became slightly more similar, then maybe play something really similar over the course of a piece, and then go back into a different way of dissimilarity again. And so this is already a meta-niveau of corpus-based synthesis, corpus-based composition, because we are here in the corpus of reconstituting a phrase with a corpus. It was ICMC 2012. Or maybe, no, I can show you this. Not there. Then let's check the videos. Okay. Yeah, this one's nice. Ah, I can't get rid of the visualization anymore in VLC. I switched it off a million times. It always comes back. Okay, so this is not a space of sound descriptors, but this is a solution space of Ben's mosaicing algorithm. So each point here is one possibility to parameterize the algorithm and to do the matching for the mosaicing. And we kind of sonify this by playing just one little word, the match of one little word which is written. So that's the target, that's one solution, that's a different solution. They're pretty similar, so they're arranged by similarity around the target here. And kind of the different angles would be different sound characters of the realization. You know, all these kind of sound similar, but the ones to the left sound very dissimilar. So these are very bad solutions because they're far from the target. Okay, so that was done with the mass string model just to get the points laid out nicely. Okay, now, so now we are, okay, already. Oh, my watch is wrong. Then maybe we can then quickly jump to again an interaction between two musicians that is made more special or enabled by corpus-based technologies, which is when the actual corpus is recorded live during the concert, during an improvisation. Usually an acoustic instrument, and then really the purest form is to start empty and record and only use sound that has been produced by the instrument player during the performance. And I think you can argue that suddenly you achieve a much stronger coupling between the two players, the two musicians, because you have this direct link. Because you're interacting with the sound space that one player generated and the other player uses. And compared to traditional improvisation, you interact in a more abstract space of musical ideas and intentions. And here we are really, it's like the musique concrète, where you really work concretely with the sound. And it actually, sometimes it becomes a kind of shared instrument. And the instrument in the end is really the sound space that so one player produces and the other kind of consumes. Or even, sometimes it even becomes kind of symbiotic, that one feeds or nourishes and the other feeds on that sound space. Or one musician once told me that sometimes he feels like a puppet when I play back little segments and little phrases that he played a few minutes ago. He feels kind of controlled by me. And I show you a pretty old video example, but that has also a 3D visualization of the corpus as it's being built up and used in a very nice little project with the NC Design School in Paris, headed by Roland Cahen, who's got a very nice piece also in the exhibition. And so that is Etienne Brunet, and you see that each little sound he plays starts to enrich the corpus. So here each note is visualized also according to its descriptors in 3D position, angle, color, size of these feather-like objects. And so when I've got a little bit to choose from, I would start playing back bits of the corpus, start navigating through and create new structures, new timbral evolutions of the sound. And then the things fill up. And it also creates a visual space. And Etienne saw also what he created, so you could postulate another feedback path of him creating the graphical space and being inspired by it at the same time. Okay, but let's move on quickly. Okay, so that was all corpus-based interaction for more expert musical uses, but we're more and more going into installations and uses for the general public. Well, there's also one observation that corpus-based synthesis is very, very good for environmental texture synthesis. You know, wind, rain, water. Here's an example of interactive wind synthesis. You know, here we've got a couple of wind sounds, and again, we can recreate the temporality, the temporal evolution of the wind by interaction. Because we have this efficient interface and still simple, the different personae of the wind completely laid out and accessible at will, and the grains are long enough so the micro-temporal structure of all these grains, or fire and of rain sounds, that's always kept. And one application of this was a augmented audio reality installation that is actually still running. It's made for a park in Paris, but you can actually download the app and just start it up anywhere, and it will place you on the virtual map, and then you can walk around and it will not correspond to where you actually are, but still you can explore the soundscapes. So we put virtual water on the slopes of this very steep park, and according to the slope it would be a torrent or just a stream or maybe a little pond, and you could actually also interact with the water by shaking and could splash water around. And so this spatial navigation here is of course then it's very literal, but it kind of makes you really explore the park much more than you would otherwise do. Yeah.
I think that we can come to save a couple of minutes for questions.
Yeah, that's exactly what I need. And this one you can actually try out in the exhibition, but I just want to show you its use with children, because these are the expert users for that kind of interface. And well, we wanted to do it because the interaction here is tactile and complex and non-reversible. But it's also very dynamic and expressive. And so we got invited to this children's place. We had a real animator who does introduction to sound for children. So she just learned that you can play precisely specific bits of sound here, or you can do the big whooshes of sound if you like. And so that version is actually running on iPad, everything, the detection and the synthesis. What you have outside is something running on a bigger computer with just via USB. And so we can conclude, well, that's just a technical thing, that it's nice to, sometimes it's nice to browse and to know exactly that one point has a certain pitch and another. But if you have these very nice 2D surfaces, sometimes you also want to use the whole surface. So I had an intern develop a physical algorithm that just pushes the points apart while still keeping the relationship between the points. So you will still know that going from left to right will raise the brilliance, and going downwards, upwards raise the pitch, for example. And that found a surprising use for the control of spatialization. Won't go into details here. And then it's time to conclude. So we saw that interaction with the corpus is very desirable because you can make use of this huge amount of sounds that you already have in your hard disk and still control it precisely. However, now you have to choose if you want to do the big gestures or play finely, and maybe that would require different solutions to the interaction, and maybe something like zooming or so, or a different choice of corpora. It's finally your choice if you want to have variety or fine details that you can play with. And if you don't do too many transformations or too grainy sounding things, the corpus-based synthesis does not impose its own kind of sound, because you really hear the source sound. So we could argue it sounds transparent. Of course, you will always hear the interaction you do with it. That's kind of telltale. I hope you agree, it can allow expressive musical play. And just for the things that are still to be more worked on more profoundly is this co-location of information I mentioned before. However, one possible solution is actually to not rely on visual information and just memorize the layout of a corpus, which I had the pleasure to perform a piece written for corpus-based synthesis where the principle was no screen, was loads of controllers, the XY pad and no screen, and it's actually a very, very good experience to not having to look at something and just listening, just being there with the audience. And I think we have for the future, we have very promising pointers of using machine learning to again optimize the interaction. Stefano Fasciani has done big steps into that direction, and also Dan Stowell has a great way of mapping one complex corpus onto another, maximizing the variations despite of the internal shapes of the corpora. And also 3D interfaces would be a lot of fun to play with, and I think no one really has done this seriously yet. So up for you maybe, or your students. Okay, and then with this credits page, I'm open to any questions you might have. Thank you.
We'll open questions from anyone, everybody?
Yeah, Stefano.